Thank you very much for having me here today representing DolphinDB. What is DolphinDB? First of all, DolphinDB is a high-performance time series database. On top of the database, DolphinDB also has a batch processing framework and a stream processing framework. There is a fully featured programming language and more than 1,500 built-in functions. You can use DolphinDB to store huge volumes of tick data or other types of data, to develop quant trading strategies and calculate trading signals in real time. Last but not least, DolphinDB is developed by a team of Wall Street veterans and is purpose-built for quant finance use cases. So next, I'm going to go over DolphinDB architecture very briefly. There are three types of nodes in DolphinDB cluster: controller, data node, and compute node. DolphinDB is a distributed system, and you can easily scale out horizontally by adding data nodes or compute nodes. If you have a lot of compute-intensive workloads, you can start some compute nodes for these workloads to achieve separation of storage and compute. Other workloads can be carried out on data nodes for optimal performance. We developed three types of storage engines on top of a built-in distributed file system that offers high availability, scalability, and ACID compliance. A data node also includes an independent batch processing engine that offers SQL, machine learning, and general MapReduce capabilities. Third-party applications can access DolphinDB via SDKs, and we offer SDKs for virtually all mainstream programming languages. DolphinDB can access other systems via plugins. We have over 100 plugins. DolphinDB can be used in a lot of quant finance scenarios where high performance is essential and the quick development is a huge plus. For examples, market data center, strategy development, real-time signal calculation, algo trading, market making, risk management, and metrics platform. For each of these scenarios, we have clients using DolphinDB in production. DolphinDB has over 100 paying clients in the financial sector, mostly investment banks, hedge funds, and mutual funds. DolphinDB is natively designed as a distributed database and offers ACID compliance and strong consistency. It offers high availability for data nodes, controller nodes, and clients. It only takes a few milliseconds to retrieve, for example, a stock's tick data in a minute from a table of 20 terabits. Flexible partitioning scheme, data compression, and threading pool computing model together guarantee optimal performance, especially with high query concurrency. Quite often, we need to do table joins on trades and quotes. We recommend trades and quotes use the same partitioning scheme so that the joins can be conducted in a co-location way, and it's super fast. The compression ratio for tick data is usually between 4 and 10. We can use array vectors to store bids and quotes. It's more convenient to manipulate bids and quotes with array vectors. Array vectors also have higher compression ratio. In-database analytics is a major advantage of DolphinDB. With huge volumes of data like tick data, in-database analytics can significantly improve the performance of batch jobs, such as factor calculation and backtesting. By conducting the computing tasks in database, we eliminated the need to move data and convert data formats between database and analytics system. DolphinDB SQL is compatible with standard SQL. It supports very complex SQL query with multi-table joins. We also offer some extensions to make SQL more impressive and more convenient. SQL queries can conduct automatic, parallel, and distributed computing, which is completely transparent to users. We have more than 1,500 built-in functions, and our clients love them. The vast majority of analytics tasks in quant finance can be conducted in DolphinDB with the help of these functions. For example, there are about 100 moving window functions, as of join and window join functions. These functions are all carefully optimized and are extremely fast. We also keep adding new functions each time when we release a new version. This example is the word quant factor number 98. It's a very complicated factor with 5 levels of nested functions. Some functions are cross-sectional, some are time series. In DolphinDB, pretty much all you need to do is to replace the functions in the definition with the corresponding DolphinDB function. And it runs very fast. With 10 years of daily data of US stocks, it only takes less than 10 seconds to calculate this factor. A few words about the programming language. Other than SQL, it also supports vector programming and functional programming. For some loops that can use vector programming, you can use JIT to speed up calculation. All of our clients also use Python. We recently released the alpha version of Python parser, which is a native Python runtime within DolphinDB process and enables users to write Python script to access DolphinDB. Right now, it supports pure Python packages and pandas. We plan to add support for NumPy and other packages later. DolphinDB's streaming framework has a pub subsystem. It supports data replay, which I will cover in another slide later. If you have developed some pretty good factors in backtesting in DolphinDB, you can use the same factor expression in real-time calculation. This is what we call unified stream and batch processing. Compared with the usual approach of developing factors in Python in research and implementing them in C++ in production, it can save you a lot of time in C++ development and results verification. Another important feature of DolphinDB's streaming framework is built-in stream computing engines. You can pipeline these engines and conveniently implement all sorts of real-time calculations. All the functions used in streaming are optimized with incremental computing. The latency of a DolphinDB streaming framework is pretty close to C++. Lastly, DolphinDB streaming also supports high availability. Here are some of the most frequently used stream computing engines in DolphinDB. For example, time series engine for OH, LC bars, cross-sectional engine for index intrinsic values, reactive state engine for nested window functions, as of join and window join for joining trays and quotes in real time, etc. And this is an example of a complex factor. Real-time data is ingested a number of data sources, and it can go through 4 or 5 steps, including minute bar calculation, table join, stateful computation before we get the result. In DolphinDB, a stream engine's output can be another engine's input, so it's very easy to pipeline these engines to implement complex factor logics. An important use of the tick data is to develop high-frequency trading strategies. For that, we need data replay. In DolphinDB, you can replay data in the database using SQL statement to specify data sources. It's very efficient as there is no need to move data around. We can also replay multiple data sources with different schemas, such as trays and quotes, into one table. These are some of our frequently used APIs and plugins. I'll give you one example about what we did to address a specific problem in quant finance. If you think tick data is large, factors data may be even larger. As for each stock and each timestamp, there might be thousands of factors. When we use these factors, most likely we use them in the white table format. So the common practice is to store these factors in the white table format. The problem with this approach is that it's very inconvenient to maintain such a factor table. In a white table, each partition contains all factors. Very often you need to update or delete factors. But even to update or delete one factor, you need to rewrite an entire partition with all factors. This is the case for all columnar databases. If you store the factors in a narrow table and make each partition contain only one factor, when we need to update or delete a factor, we can just rewrite or delete the partition for this factor without affecting any other factor. This can be 100 times faster than the white table format. However, to use these factors, you need to convert these factors from the narrow table format to white table format. And it takes a long time if you have to retrieve the data from the database to another system to do so. In DolphinDB, when we retrieve factors from a narrow table, we can use the SQL pivot by statement in DolphinDB to convert data into white table format. As we usually need to retrieve a large number of factors for each query, the pivot by operation can be conducted in parallel. We did a lot of optimization in this respect, and in the end, the query performance of the narrow table format is actually better than the white table format. Now, a lot of our users adopt this narrow table format to maintain their factors. I'll sum up with a few major reasons why our clients chose us. They need a high-performance database to store huge volumes of data and to keep their data secure. They would like to conduct the vast majority of their computation inside the database, instead of moving huge volumes of data to another system for analytics. They appreciate the convenience and high performance of our built-in functions. And they save a lot of time by using the factor formula developed from backtesting in streaming. Thank you very much.